Today I will introduce to you a cost-effective and simple way to protect your SolidFire or NetApp SCSI data on volumes presented directly to virtual machines running in a vSphere environment. These virtual machines can be Linux or Windows. It works for the both, and it is slightly different from the usual method of data protection via maybe taking snapshots or backing up to traditional backup software. So as we shall see here, the usual approach for everyone is to take a clone, which is a crash consistent clone, made by the method of taking a snapshot of volume, and then generate a copy. Now, this copy, once generated, can be easily presented to another storage user. So in this case, if we created a snapshot clone of a volume presented to the Trident virtual machine, give this volume to another user in this environment, and this user could then use iSCSI to access this volume. Of course, we could also use other approaches. We could expose the same volume back to the same virtual machine that it originated from. We could mount it at the same time as the original, then copy data from one to another. We could also take a clone of this clone and then expose the clone to the Trident virtual machine, and so on and so forth. But by having a clone and exposing it to another virtual machine, this clone is now completely, in the sense of access and permissions, accessible only to this backup user. And on this backup virtual machine, we can then install a backup utility that can take a backup and store it offsite, or at least in another storage. So in this case, we have a NetApp StorageGRID cluster. The backup VM will save the data to. Then, as we need to restore, we can now restore either from the clone volume, which is still present, or directly from NetApp StorageGRID S3 bucket by deploying the backup utility, CLI, either on the virtual machine that needs to be restored, or by restoring it to the backup virtual machine and then copying data to the Trident virtual machine. As data gets updated on the source volume, we would use the volume-to-volume resync, which would help us avoid the creation of repeated clones, and it would also make this synchronization very rapid, because only the part that is different would be resynced, and then only the part that is different would be resynced, and then the backup virtual machine could take incremental backup and send another thin backup to NetApp StorageGRID. So this is what we will use in today's demonstration, as opposed to standard virtual machines for which the issue of backup in the VMware environment has largely been solved. NetApp SCSI and SolidFire work with Veeam, Commvault, and Rubrik, so the question of restoring this is fairly easy. But today's use case is for volumes presented directly to virtual machines outside, and in this slide we'll talk about this process and how we can automate it. So in the IQN of an average SolidFire target, we have first the common string, followed by a cluster ID, followed by the volume name, which can repeat across different volumes within the same cluster, and then last but not least is the volume ID, which is returned by the SolidFire API, and we cannot change it. So this volume ID is unique. When we clone a volume, we can give it an arbitrary volume name. It can even be the same as at the source, but the SolidFire API will return us a different volume ID. So this structure makes it very easy to create volumes that have a prefix or even the same name, and pick the returned volume ID of the new volume, and then handle this at scale. As many volumes are created, we can, by getting the ID from the clone, mount these volumes at a location that at is the same as their volume ID of the clone, and we can do this at scale and automate easily. And then naturally later, as we need to update the clone, we can do a resync rather than take new clones. So this structure can be nicely represented with pairs of source and target. If we were to automate this or write it in PowerShell, a new SolidFire clone would require the input of volume ID, which is the source. We would pick name for the volume of the new clone, and then the account to which we want to assign this clone. 174, the new volume ID would be returned by the SolidFire API. And then on resync, we would just have to run the copy as a volume commandlet and specify the source and target to bring this target 174 in sync with a crash consistent snapshot that is made on the fly of volume ID 171. So this is roughly how this process can work. It should be easy to automate, and like I said, we could have a file with rows that consist simply of a couple of values: source volume, destination volume, or maybe just the source volume, fill it with destination volume value, and name perhaps for the clone, and then this could be updated and the rest could be automated. So only a list would be necessary of source volumes that need to be backed up. So this is the environment in which we'll show how this works. So we have a virtual machine solid backup, which is the backup VM from the previous slide. This virtual machine has its own account, so you can see it's running at the IP 1.134. As we take these clones, they will be space efficient because they're thin clones. Only the metadata of the volume is using space, while data is deduplicated and does not repeat. So these two volumes that we see right here belong to the backup virtual machine. These are not container volumes, these are just regular volumes that could be used, for example, or could be clones from other volumes in the cluster. We can see here that these volumes are approximately 50% full, whereas in the UI we can see they are about 35% on average full, which is due to compression and duplication. Any clones of these volumes would take zero space as long as they don't differ from their source. So we created some random files in here, and now we could run a backup. Duplicacy asks you to first run the init command, which basically specifies the source directory from which you are taking backups, and the target, which can be either local file system, it can be SFTP, and other sources. One thing that should be mentioned here, that SolidFire has a built-in backup to S3, also to Swift and another SolidFire cluster, so we could use that as well, but for the purposes of this demo, we will not use this approach because we find the approach that we are demonstrating much more useful. So after this init command, which we use to specify this /mnt as the source and NetApp StorageGRID as the target, we also created the bucket prior to that, so that this backup init can find this solid backup bucket and initialize the cloud destination as well. So we saw that before we had two volumes with about 900 megabytes each. We took a lot of backups, and they still take up only about 500 megabytes on StorageGRID. So compression and duplication happens on the backup VM, and it's done by Duplicity. After that initialization has been complete, we would run a backup, then we would use the list command to see what we have backed up, and then we could restore any of the so-called revisions or incremental snapshots from the backup destination. So this is as far as local volumes are concerned. Now, the Docker virtual machine is a special case. So this is the second virtual machine, same configuration, but it is running Docker with NetApp Trident with a SolidFire SAN backend. So this is what's different about this virtual machine, and this is the reason why I created this demo. We can see we have Docker up and running, and its storage is managed by a plugin from NetApp Trident 20.07, and there are 2 volumes created by this plugin for Docker containers. If you go to SolidFire accounts and find this account, we'll see that these 2 volumes, DB1 and DB2, they're each is 1 GB large, and we can see how they're being used. So currently there is 1 container that is up and running, MySQL 1. It's running MySQL version 8. If we check this container and see whether it's using any volumes, I have to fix the typo, but now we can see that this container MySQL 1, it's using the volume DB1. So similarly, we had another SQL running for the other volume DB1. So similarly, we had another SQL running for the other volume, but it is not essential to our demonstration, so this will suffice to say they are less full, but different in size. So now, if we wanted to back up these containers, it's a little bit hard because Docker can reschedule them, Swarm can fail them over, Kubernetes can allocate them or start them in different places, and also there are no mount points like there is in a regular virtual machine. So this is why we will use the cloning approach. And if we go to volumes, we can see that this has already been done. So I can do this from the UI, or as per the PowerShell command line that I've shown, here the DB1 volume has a clone in the form of backup-db1, but you can see that each clone belongs to a different user, and then volume 172 has been cloned into volume 175 that was assigned to the backup VM. So now in the backup VM, it's backup-db1 and backup-db2. I could make these volume clones in the UI as well. It's very easy. Pick a new name, pick the account. So this is a new account ID, and then within seconds, because only the volume metadata is copied, a clone has been created, and we have a new owner for this volume. Now I could add it to the access group for Solid Backup, but I can remove this volume. I don't need it for demonstration. I just wanted to show how these 2 volumes have been created previously. So when we automate, we would not use the UI, but I'll show you now these 2 volumes. Going back to the backup VM, these 2 volumes are already visible on this virtual machine where I had those 2 mounts, 2 GB mounts. Now you can see that there is dev-SDD and dev-SD. Each of them is 1 GB large. So those other volumes that were previously mounted, they are there, but then the new volumes, they are not mounted. These 2 are there, but then the new volumes, they are not mounted. These 2 are the clones from DB1 and DB2 created by NetApp Trident. So in order to back up these, obviously I would mount them as well. So I would mount them where? To a mount point that equals their volume ID. So this way, when I resync volumes 171 to 174 and 172 to 175, I always know where my volume is and which volume is where. It is also easy to automate because the volume ID then equals the mount point. So if I look underneath each of these directories, I can see that they're different. Running MySQL in those containers has an account ID that is not present on this system, so that's why a little bit later in the cases where I need to read those files not accessible to others, I will have to use the sudo command to back up these volumes. But in any case, with these things, so now I have both the original SB1 and SB2 volumes that illustrate backup of local disks that are ordinary disks, as well as containers mounted here. And the other thing that I mentioned is, as we create the first clone, later on we can update this clone by resyncing the source to destination. So to do that, we can use SolidFire PowerShell tools or SolidFire Python CLI or the API directly. So in this case, I'm using in the same Solid Backup virtual machine, I have installed PowerShell 6.2 installed PowerShell 6.2. And now, if I wanted to resync this virtual machine, this volume 171 to volume 174, I would run the commandlet copy volume. Sorry, this is a little bit hard to see, but it says dash volume ID 171, DST volume ID 174. So this is how I would resync periodically these two volumes, and then I would constantly back up the volume from the mount point in the backup virtual machine. So now, since this is already synced, I would now go to the Docker virtual machine, and I will show you the recovery that could be done from the clone. So what I'm doing here is I'm entering the MySQL VM, MySQL container, and in this container I can see where the mount point is, which is where DB1 is accessed. Now in here I can do some make some breaking changes. For example, I should create a file that shouldn't exist here. I can also remove certain MySQL data, such as transaction logs. And with this database now, if I were to restore it, I shouldn't see the first file that I created with the touch command, and then I should see those other files that I deleted. Since this MySQL 1 instance is no longer good, I can kill it. And now I will use the same command that I just started demonstrating a minute ago to synchronize the volume back. So I will synchronize volume ID 174 to 171. Of course, the first line of defense would be snapshots. So I just demonstrated it's also very easy to create snapshots. So you would probably take regular snapshots and keep them around for a few hours. But this is about backups. So I will not demonstrate the use of snapshots. So I will demonstrate how I could reverse sync volume ID 174, which is the clone, to its origin, which is volume 171. So I run the same copy as a volume commandlet, but now I specify volume ID 174 as the source and the other one as the target. I get an ASIC handle, which kind of lets me pull the status of this job to see when it is finished, so that I know when I can mount or use volume DB1. So volume 171 can be used once this synchronization has completed. Since the volumes are very small, there's only 1 to 100 megabytes of data, I can quickly restart this container, and then if I go into the container, I can check whether the file that I created is there. So that one was removed, and then all the binary log files, they are there in their place. So the recovery are all ways that I could use to get to the data from the clone. Like I mentioned earlier, you can again notice that the clone and the source belong to different users, meaning the clone is relatively better protected in the sense of user not being able to access those volumes from the container where they were created. Now, once I've started MySQL 1 on the Docker virtual machine, it's being updated, so I need to resync 171 to 174 so that I have the latest data there. And once that is done, I can remount it on the backup virtual machine, and then I can run my backup against these directories. The other volume, 175, has not been updated because that MySQL 2 is down, so that one is still at the source. So now I have 4 directories. The 2 files, SB01, SB02, those are files that I kind of maybe use for some IO-heavy programs connected to eSeries or something else. And the 2 others are clones from Trident volumes. So I mentioned already I did a sync, and I did the init already, and then now I would create a filter file which is in the duplicacy directory, and that file would say backup these 4 directories. So data 1, data 2, 174, 175. So you can see the hidden directory with the settings. Now, before we back up, I can create some random files in these directories here. been updated or uploaded to destination. Now the list command tells me about all the revisions that I have. So the initial backup is the one that backs up all the data. All the revision backups after it are incremental and only recorded changes. Since I'm restoring these files, they are not present, so in revision 21 they wouldn't be there, but I will remove them now, and then to restore them I will use the latest revision. So I can remove a few other files, let's say ca.pem, from the clone of MySQL database. The restore command takes a parameter of the option of revision, so we would use the latest one, which is number 22, and then full path to the file. We can restore in place or to a new location. The first one is the job2.txt file, the second one is ca.pem. They're quickly restored, and this is how restores work. Now, for some users who might wonder, wow, the CLI stuff is too hard, there is also UI, which is very lightweight. It's a single Go language binary. The eval version only lets us create local destinations, but this could be a big volume made of nearline SAS on iSCSI, for example, if you wanted to take backups to a local block device. So this has been readied, and now the second step is to define our backup. I used only one of the directories to illustrate how this works. These are very fast because they are local. So I'll create a new file, and then I will take a backup and then delete and restore it locally, so you can see how it works from the UI. So pick a file from the first MySQL database container, copy it to one of the subdirectories, actually the only subdirectory that we have here defined, and then a fraction of a second, and that is it. You can also create schedules to repeat this and also to expire older backups. If you wanted to restore, we'd go to this data store where we backed up this file, and obviously want to remove it first so that we have something to restore. Now, we only have one destination. Duplicacy GUI would allow you to set multiple, so we'll go here, find the latest backup, then we'll go to restore, pick that backup, the latest revision. We could restore in place or to another location, so I'm restoring in place now, revision 5, and then these are extremely fast because they're local. And again, this is now, this /backup is stored on the VM boot directory, so if we wanted to keep it safer, we could put it externally. If we wanted to keep it safer, we could put it externally on a serious iSCSI or fast iSCSI device. So we could also define multiple copies, so you could have one copy on iSCSI, another on StorageGRID locally, and then you could also run remote backups.